In this tutorial, I'll show you how to use pre-built components to create this effect in Touch Designer, and also using the iPhone to control inputs to this effect, such as moving it around the screen and turning on additional feedback effects and then controlling those as well. We'll be using Touch Designer FTE, and for the iPhone application we will use Touch OSC, which can be found at hexler.net/software/touchosc. Hello and welcome to another edition of Inside Touch Designer. In today's tutorial I'm going to show you how to use the iPhone as an input device for Touch Designer. You can use any iPhone model. I'm using a 3G here, but a 3GS or first generation will work. You can also use an iPod Touch if you have one of those. The first thing we need to do to get the iPhone communicating with the computer is make sure that they're both on the same Wi-Fi network. So to do that, I'll go down and check that my computer is hooked up to the Wi-Fi, and it is. It's on a network called AirNet. So then on my iPhone, I'll go into Settings, and then Wi-Fi, enable it, and make sure that I'm on AirNet as well. There we go. So now both the devices are on the same Wi-Fi network. Now, to communicate between the iPhone and Touch Designer, we're going to use iPhone apps that use OSC as a communication protocol. There are a number of apps out there. The best thing to do to find them is to search iTunes for the term OSC. OSC stands for Open Sound Control, which is a protocol used to communicate between various applications. So for this tutorial we're going to use an application called Touch OSC, and you'll see it here if I click on it to start the application, and press OK. It's a simple UI that's created with a number of different devices. These are buttons. Here's an XY slider. Here's a matrix grid of buttons. And all of these inputs are then sent as data over the Wi-Fi network to Touch Designer using OSC protocol. Press the I button for information. There's not too many settings here that you need to worry about, but I like to turn on the stay connected so that if your iPhone goes to sleep or something, you don't have to reconnect and take that extra time. And also for this tutorial, we're going to use the accelerometers in the iPhone, so we're going to turn on accelerometers. And there's a number of layouts included with Touch OSC, but we're going to use the simple layout. Here you'll see the other ones, but if you just select simple, that's the one we're going to concentrate on. And then you need to check out the network settings. Under network settings you'll see host, outgoing port, and incoming port, and then it reports to you the local IP address of the iPhone. So for the host address, we need to find out the address that our computer is on the Wi-Fi network. To do that, I'll go down and check my network here, right click on it and select status. In the status dialog, press the details button, and under details you'll see an entry for IPv4 address, and this is the IP address that we want to plug into the iPhone app. 10.0.1.2 in my case. This will be different depending on your Wi-Fi router and what IP number has been assigned to it. So I'm going to go into host, delete the old number that was there, and add 10.0.1.2. Done. For outgoing port, I'm going to change it to 10,000 because I know that the default port for Touch Designer is 10,000, so this makes it easy. But we can use any number if we match it up in Touch Designer. So for outgoing, I'm going to put in 10,000. For incoming, I'm just going to leave it. It says 9,000 right now, and that's fine with me. So when you accept that, it's going to say that it's searching, but you can just press the Touch OSC back button and then press done to get back to the interface. And I'm going to select the third tab for this tutorial because we have an XY slider and some toggle buttons that I'd like to use. Okay, so Touch OSC should be ready to go. Let's start up Touch Designer. The first way to see the raw data being sent to Touch is to open or is to create an OSC in DAT. Data operators, or DATs, deal with text data or table data. So I've just created an OSC in DAT here. You'll see data streaming in here. Let's make less lines, as 100 lines. I'll drop this to 20 lines. And you can see data is streaming in over OSC. It starts right away because the network port, the default network port for Touch Designer is 10,000, and that's what we selected on the iPhone application. And you can see as I move with the axis, you can see that the numbers are changing. This means accelerometer in X, Y, Z axis, and then you have your X value, Y value, and Z value. So this is the actual data coming in from the application in raw text form. This can be very handy for debugging or trying to figure out the actual syntax that different applications use when they send their data through OSC. Most applications all have their own sort of flavor of syntax, if you will. A more straightforward approach or simple approach to getting data into Touch is to use the OSC in CHOP. Now what it'll do is just create channels for each channel of data in Touch. So I'll create an OSC in CHOP. Now you can see 3 separate channels, all with a single number. And each channel corresponds to a certain axis or accelerometer in the iPhone. Again, it works right off the bat because the network port default is 10,000, and that's what we've set the iPhone to look at. So right now we have it coming into both the OSC in DAT and the OSC in CHOP. Now for our purposes, we're just going to use a CHOP. We're just interested in these raw numbers. So by default, the accelerometers come through. You'll notice if I then use any channel in the application, that channel is then added to the OSC CHOP. For each fader I move here, another channel is added, and the data follows quite smoothly. Now, if you ever want to get rid of these extra channels, because you might not need this fader, for example, you can go to the Reset Channels button in the parameters. If you click that, you go back to the default channels that are coming in. It just clears all the extra channels. We're going to use the accelerometer today, and in this layout we're going to use the third tab. It has an XY fader and a few toggle on-off buttons. You'll see the channels in Touch Designer for each one of these buttons have now been added to the OSC and CHOP, as well as the X and the Y. So now that we have our data coming into Touch, you can see the accelerometer is working, and my XY control is working, Toggle's working. Now we're going to do something fun with it. We can open the browser, which is open on the left side of the interface. And under Techniques and the SOP folder, you'll find a component called Particles with Feedback. Drag and drop that onto the network editor. There we go. Now you'll see the particles start playing back. You may get some feedback instantly. Now I'm going to add a null top to the network. This is really just a top that I can display my final result with. And I'll turn on the display flag so we can preview this in the background. We can see what we're doing to it as we work. Let me move this over here. Now, we'll go to Video and Filter folder in the palette and find actually scratch that. We'll go to Shaders and find something called Light Tunnel. Drag and drop it to the network as well. So I'll connect it in line and then connect the output of the light tunnel to the null top. There we go, this is the light tunnel effect. And I can zoom in here and turn on the interface. And here we can move around the center of the light tunnel using this XY pad. Okay, so that's not bad. In between this, I'm going to put a level top just to bring down the level of the colors a bit. Level. Drop it in line. Open the parameters for it by pressing P. And on the range page, I'm going to bring down the in-low parameter to something about 0.5. Cool. Now I got sort of like a disco ball nightclub light effect. Something a little more what I was looking for. And again, I can use this light tunnel to move where that is catching the image. Okay, so let's use the iPhone to actually move this around. To do that, we know we can use the accelerometers. I'm going to tilt the iPhone this way to move it in X, and tilt the iPhone this way to move it in Y. So if I look at these channels here, that first channel, ACC XYZ1, is the first axis that I want to capture. So I'm going to right click on the output of that node and add a select chop. Open the parameters for it. Under channel names, select ACC XYZ1 from the menu. Okay, so this is just that one channel. Great. Now I want the other axis right here, and I can see that that is ACC XYZ2. You can just see it because it's moving there, so I'll add that as well. Right, now I got my two axes that I want to use. Before moving forward, I'm going to close the palette browser to make some more space, and then I'm going to split my workspace into two panes like that. This will allow us to preview the chop channels on the left side while going inside the light tunnel component on the right side. and investigating where we can hook up these channels. So I'll select the light tunnel component, press enter to go inside, and we're looking for the 2D slider that manipulates the position of the light tunnel, which is right here. We'll select it and go inside one more time. Here you'll see the actual panel component that builds the 2D slider. You can bring up the parameters and go to the panel page. And here you'll see an override chop parameter. This can be used to override the values that control this position. Namely the U and V values. X is U and Y is V. So we can go over to our chop, append a null chop to the end of the chain. It's always a good idea to export channels or make connections from a null chop. So now that we have that, we can drag that to the override chop parameter. It'll ask you if you want to use relative path or absolute path. I'll use a relative path in this case. Okay, so as soon as we connect it, you'll see that this panel moves up to the upper right corner. We need to name our channels appropriately so that they override the correct panel values here, namely U and V. So if we go back to the select chop, open the parameters, and the rename to field, we'll rename the channels to U and V. There we go. Now let's see. There we go. You can see that the iPhone is now moving that 2D slider. However, the ranges aren't quite right. The values coming in from the iPhone don't match the range that we want for the 2D slider. So to figure out the range, I'm going to temporarily remove this connection to the override chop parameter just by deleting that path string. And I'm going to manually move this from edge to edge to see what boundaries we want. If I go to the left, right about there is as far as I'd like to go. That's about 0.2. And then to the right, about 1.1. For V, about the same, down to 0.2 and up to 1.1. So what we can do is connect that null chop again to the override parameter. And between the select chop and the null chop, add a math chop. Now by looking at the channels coming in from the iPhone, we can see that the range is -1 to 1 for both accelerometers. So in the math chop parameters, I'll go to the range page, and the from range will be -1 to 1. There we go. Now the to range we just identified as wanting 0.2 to 1.1. So we have the U channel working, however the V is not doing anything to the slider component. So we'll go over to the parameters on the slider page of the slider 2D component and change the slider type to slider UV. Now we'll see if that's working. Yeah. However, I'm going to invert the V. I want to actually have the iPhone do the opposite. So to invert the U or V channel, I'm going to need another math chop. Let's first rename this math chop to range, since that's what I was using to rearrange the numbers. And move these over. I'm going to add another math chop before the range. Here. and we'll call this invert V. Go to the common page on the parameters, and under scope, set this to V so that this chop will only operate on the V channel. Then go to multiply, -1. And we can see that's inverted the channel. So that's great. Noticing that on the right and at the top, it doesn't quite go all the way to the edge. So I'm going to go back to this range chop and increase the to range to maybe 1.3. So that's better. Edge to edge. Okay. Now it's a little bit jerky, not so smooth, so before the null chop I can add filter chop, which will smooth out the inputs of the accelerometers. There. Now that's a little slow, so I'm going to take the filter width down to just under half a second. It's still a bit slow, maybe 0.3, third of a second. That feels better. Smooths it out a bit, takes some of the jerkiness out of it. It still feels relatively responsive. The next thing I'd like to do is to use one of the toggle buttons here on the interface to turn on and off a feedback effect that we can add. So first, I'm going to identify which channel here is this first button. It's called 3/toggle1. So using the middle mouse button on the output of the OSC in chop, I'll click and create another select chop. Using the middle mouse button will create a new branch in the network as opposed to adding the chop in line. So I'll just move these down a bit. And in this select chop I'm going to select that channel 3/toggle1. And in the rename to parameter, I'll rename this channel to something more obvious, like feedback. And add a null chop to the end of that to prepare it for exporting. Okay. Now if we open up the browser again on the left hand side of the interface, we'll find a feedback component under the video and filter folder. Feedback, if we just drag and drop that onto the network. There it is. I'll close the browser again so we have more room to work. And what I'll do is I will put it in line. Connect the light tunnel to the input of that, and the feedback to the null chop. You can already see a little bit of feedback happening, but it's more apparent if we move the direction of the feedback, maybe give it a little more strength, and turn on the Luma key for it. There we go. So you can see the feedback effect here. I can control the motion or the direction of it using this XY slider in the control panel here. But to start, all we want to do is connect a toggle button to turn this effect on and off. So one way of doing that is to add a switch chop in the network. I'll add it to the output of the feedback. Switch. And then connect the light tunnel to the switch as well. So now I can switch between the light tunnel as the main input or the feedback. That's the light tunnel, that's with feedback. So we basically need to get this feedback channel controlling the index parameter on this switch top. So what we'd like to do here is connect the feedback channel in the null 3 chop over here to the index parameter of the switch chop here. So to do that, I can turn on the viewer active flag for the null chop and then drag and drop the channel directly to the index parameter. In the menu that pops up, just select export chop, and the export connection is made from the chop down to the switch chop. So now if I try this toggle button here, you can see it goes from on to off. Now I'd actually like it so that when this button is on, the feedback is on, and when it's off, the feedback is off, which is the opposite of what we have. So there's two ways of dealing with this. We could either invert the channel value here using another math chop as we did above, or we can just go down to the switch top and switch around the inputs, which is how I'll do it. Now, feedback is on with that first button, feedback is off, on, off, on, off. Alright. Okay, so that was pretty simple. Now the final thing I'd like to do in this tutorial is use this XY slider on Touch OSC to control the XY direction of the feedback effect. So we want to tie this to this little control panel gadget here. So I'll minimize my pane. And over here on the right hand side, I'll go back up a couple levels. You can press U to go up a level, and then I'll select the feedback component and press enter to go inside it. Now again, we want to find that 2D slider. Which is over here. It's called translate. Select it, go inside. And again, it's one of those slider 2D components. So I'll select it. On the slider page, change the slider type to slider UV. And on the panel page, well, get it ready for a chop because we need to select more channels from the OSC and chop over here. So I'll middle click on the output of the OSC in chop, create another select chop, place it down, open its parameters, and for X and Y with this control panel, you can zoom in and see that it's called 3/XY1 and 3/XY2. So we could just go select those channel names here. And we'll rename them to U and V again. There we go. And then we'll append a null chop. And then we'll take this null chop and drag it over to the override chop parameter. Select relative path, and there's the connection. So you can see that that's already working pretty good, but again we need to invert the Y or V value. So I'll go and insert a math chop in between the select and the null chops. On the common page, select V again, and then multiply this by -1 on the multi-add page. That's actually not what we want to do. Put that back to 0 or to 1. Go to the range page and take the to range and go 1 to 0. Now you can see that the XY controller on Touch OSC corresponds perfectly with this component, the feedback component, right there. So, by moving the iPhone around, you can move the light tunnel. Let's get a better look at this. By moving the iPhone accelerometers, you can move the light tunnel effect around. You can turn on and off the feedback effect that we've added. And when the feedback effect is on, we can then use this XY pad to actually move the feedback effect, whichever direction we want. So if you have an iPhone or iPod Touch, hook it up to Touch Designer and start having some fun.